Here are some warm-up problems that will help you with our lesson on compound inequalities. Just go through these 5 problems, and they're multiple choice, so pick the best answer. Feel free to check with your neighbor to make sure you're getting the same answers. Pause the video now. And those were actually quite straightforward, but a good review of open circles and closed circles. And for number 1, I'm not totally sure why that 3 is there. I just ignored it, assumed it was C is less than 8. Alright, let's move on to today's learning target for this lesson. We're going to learn about compound inequalities today, and so by the time the lesson is done, you should know what a compound inequality is, how to write one, and then how to solve them. I like to start off explaining a compound inequality by explaining a compound sentence that you would have heard of in English. And I want you to think for a moment about what a compound sentence is. And hopefully you answered that a compound sentence is when you put 2 or more shorter sentences together. And there are words that join those compound sentences together, and I know 2 of them specifically are and or, and those are the ones we're going to use in math class. So a compound inequality is merely just bringing together 2 inequalities. The first set of inequalities we're going to look at are the ones that are joined together with the word and so that's why you'll see this word and up here on the slides if we're talking about compound inequality with and. Alright, so let's explore how these work. Here it says you can write a compound inequality. X is greater than or equal to -5 and x is less than or equal to 7. And so the word and means that the values of x have to be true for both inequalities at the same time. And you can actually rewrite these 2 compound inequalities as one inequality statement. So notice what it says. It's still saying the same thing, that x is greater than or equal to -5 and x is less than or equal to 7. Well, think of some numbers that you could put in for x that would make both of these statements true. Hopefully you thought maybe 5 would be an answer, or 6 is an answer, or whatever, 1 is an answer. All these numbers in here, all the way from -5, including -5 as well, up to 7. All these values here and the decimals are solutions to that inequality because they're true for both statements at the same time. So let's do an example where we have to write a compound inequality using the word and. Our job here is to write a compound inequality that represents each of the situations, and then we're going to graph the solutions. So the first one, letter A, says all real numbers that are at least -2 and at most 7. So I like to actually graph them first, to start out. So we know that the number is at least -2. Can it be -2? I think so. And it is at most 4, and I think again that it can be 4, so I will close my circles. Well, what numbers lie inside of there? All these, which I will highlight. And so now I like to start to write my compound inequality, and I'm going to write it as one statement instead of the 2 inequalities separately. And I like to use my graph to help me. My values or solutions are that red line there, so those are my x values, my solutions. I have an upper boundary of 4, so I write that on the right side, and I have a lower boundary of -2, and I write that on the left side. And you know your x values have to be greater than a -2. Now notice I'm reading that backwards. I've always advised you that you should start at the variable and read backwards, if you have to, for a inequality. Then, compared to 4, all your x values are less than 4. And so there you have it. You've written your compound inequality. Now a little hint is these inequality symbols will always face the same direction. They're never going to be opposite directions. So keep that straight. And that's for compound inequalities using and. Looking at letter B, it says today's temperatures will be above 32 degrees, but not as high as 40. So if you're above 32 degrees, and I have a bad chart here, so let's just remake a new one. and we'll just write 32 down as our boundary number. You're going to be above 32. It didn't say you'd be 32, so we're going to open that circle. But you're not going to be as high as 40. So again, that's another open circle because you won't actually be 40. Your values that will be included for temperatures lie between these two numbers. And so when I write my compound inequality, again, your solutions are in the center. So we'll put X there. And then I'll start with the 40. My solutions are going to be less than 40, but at the same time, they're going to be greater than 32. All right, let's have you practice a couple. And we'll just look at these. Guided practice 1A and 1B. So go ahead and read them, and I advise that you graph them first, maybe to help you write your inequality. Pause the video now. So you can take a look at those. I think 1A was pretty straightforward. 1B, I'm guessing that word inclusive means it's including those boundaries. I wouldn't ever do that to you, but I just put equal signs on those, and now that I see that, I should have colored these in if I'm going to say it's that. But the more important part is that you had an X on the interior of that compound inequality and that your symbols are facing the correct direction. So now that we've written compound inequalities with the word and, we're going to talk about solving compound inequalities joined by the word and. You'll be happy to note that solving compound inequalities are really no big deal. So you should write down this compound inequality and notice I have a problem in the center, and that is my R is not isolated. Your rules still apply. Your goal is the same, to isolate your variable. You're going to still use inverse operations to get there. The difference is the golden rule. Remember, that usually says whatever you do to one side, you do to the other. For compound inequalities, whatever you do to the center, you're going to do to the two ends as well. So you're just going to have to do one more step before you're finished solving. So let's actually solve this solution, or solve this inequality. My R is right here, and I need it to be isolated. And 5 is being subtracted from it, so you're going to add 5 to the center, and to the right side, and to the left side to make sure that this thing doesn't change fundamentally. And then simply simplify all three parts. You'll end up with a 1 on the left, your R is isolated in the center, and then you're going to have a 4 over on this side. So when you solved this, you ended up with this compound inequality. That R was greater than 1 and less than or equal to 4. Let's graph it. My 4 is going to need to be a closed circle. My 1 will be an open circle, and your values or solutions are between. You try 2A and 2B. Again, whatever you do to one side of the inequality or the center of the inequality, you have to do to the two ends as well. Pause the video now. Alright, for 2A, it's pretty straightforward. You had to divide all three sides by 3 in order to isolate X. Make sure you are solid and open circle. And 2 was a two-step operation. You had to add 1 to both sides, or all three sides first, and then divide by 2. If ever you have a negative coefficient here and you divide by that negative, that rule still applies that you would flip your symbols, but you just flip all of them in this case. So let's switch now and go back to writing compound inequalities, except this time we're going away from and we're going to look at our conjunction of or that's going to join the two inequalities together. In this case, we're asked to write a compound inequality where all real numbers that are less than -3, or there's that word greater than 7. This one, you'll see, has to be written separately. When I look at the numbers that are less than -3 or greater than 7, you'll see that there are no numbers that are true for both statements at the same time. That's why we have the word or. Your numbers or solutions will be found over here in this region, or they will be found over here in that region. They will not be found in both, and they will not be found in the center. Alright, let's have you practice writing an inequality. Look at number 4. It wants you to write an inequality that represents all real numbers that are at most -5 or at least 3, and then graph your solution. Pause the video. And let's talk about this for a second. I know it can be confusing when they say your numbers are at most -5, but then you kind of have to flip that around in your head and say if that's the most they can be, then it must mean that they are less than -5. They could also be equal to -5 in this case, the way it's written. And so when we write out this inequality and graph it, that's that scenario. This can be confusing too, that your numbers are at least 3. So then flip it in your head and say, well, they can be 4, they can be 5, and where are those numbers? Those are to the right of your dot at 3, which should be a closed circle as well because you can be 3. The least number you will be is 3. So that brings us to solving a compound inequality with the word or. And don't be nervous because these are straightforward too. Again, we're talking about or. So here I have a compound inequality. I have this one here or that one there for your solutions. And you'll be happy to know that you just solve them completely separately. So we're going to look at the one on the left first. And my job is to isolate this v. Well, you've done this before. I'm going to subtract 3 from both sides. You get 4v is less than a -8, and then just finish it up by dividing by 4. And you'll see that v is less than -2. Well, that's one of your solutions, but you have 2 because this is a compound inequality. So move over to the inequality on the right side and subtract that 7 off both sides. So you're left with -2v is less than -6. And again, finish that up. And look what we just did. We divided by a negative. So reverse your symbol and simplify both sides. And you should be writing the word or in between these every time you're doing this because it is a compound sentence and you need to have that word in there. So in this case, v is less than -2 or v is greater than 3. And it did ask us to graph it, so I'll go ahead and just do a line. And our boundary numbers are -2 and 3. And so, if v is less than -2, that's going to be an open circle, and the numbers -3, -4, -5, etc. will make that statement true. And on the right side, v is greater than 3, and those numbers will be found over here. Alright, your turn to practice. Number 5. Pause the video now. The only issue that perhaps you would have encountered here is that you needed to remember to flip your symbol here because you were dividing by a negative number. But hopefully you knew to solve them each separately, and then I just threw down a graph with those 2 boundary points that we needed. So I hope this video helped you achieve your learning targets of writing an inequality, graphing a compound inequality, and solving compound inequalities.